Pluto, once relegated to the fringes of our solar system and dismissed as a distant, frozen rock, has long sparked our imagination. It was once the ninth planet, the mysterious little world on the outer edge of the solar system, and for decades, our understanding of it remained limited, shrouded in mystery. All that changed with the arrival of NASA's New Horizons mission, which in 2015 provided the first high-resolution images of Pluto, revealing a planet that was far more than we could have ever expected. What we once thought was an inert world of ice and rock turned out to be a far more intriguing, dynamic place, sparking a revolution in our understanding of this dwarf planet and the potential for life beyond Earth. Today, scientists continue to study the data returned from New Horizons, uncovering more secrets about Pluto, some of which challenge everything we thought we knew about planetary bodies in the outer reaches of our solar system. Before the New Horizons mission, we barely knew anything about Pluto. It was one of the least explored and least understood bodies in our solar system. The images we had of it were distant, blurry photographs taken by the Hubble Space Telescope, which could not offer much in terms of details. The most vivid depictions of Pluto were artistic representations based on our limited knowledge, found in textbooks and documentaries. While these artistic renderings sparked our curiosity, they were not based on actual photographs, leaving the true nature of Pluto a tantalizing mystery. The reason we had so little information about Pluto was simple: it resides so far from the Sun that it is incredibly difficult to observe. The planets in our solar system reflect sunlight, but Pluto, being so distant, receives only a fraction of the light from the Sun. Additionally, because Pluto does not emit its own light like stars, even our best telescopes struggle to capture clear images of it. The light that we see from distant stars, or even our own Sun, is faint and often scattered by the vast distances of space. It was like trying to see a small object in the dark from miles away. Despite the tremendous advances in our technology, Pluto remained elusive until New Horizons arrived. The New Horizons mission, launched in 2006, had one purpose: to explore Pluto and the Kuiper Belt beyond. This spacecraft traveled for nearly 10 years to reach Pluto, and in July 2015, it made its closest approach to the dwarf planet. New Horizons did not disappoint. For the first time, we were able to see Pluto as never before, and the images it returned were nothing short of breathtaking. Scientists and the public alike were amazed by the clarity and detail of the images that New Horizons sent back to Earth, revealing a Pluto that was alive with activity and more complex than anyone had anticipated. One of the most striking features of Pluto's surface was the discovery of vast, heart-shaped patterns on the planet, specifically in the region known as Tombaugh Regio, named in honor of the astronomer Clyde Tombaugh, who discovered Pluto in 1930. This heart-shaped region stood out not only for its striking appearance but also because it was completely unlike anything scientists had imagined. The western part of the heart, known as Sputnik Planitia, was covered in vast plains of nitrogen, methane, and carbon monoxide ice. New Horizons also detected a thin atmosphere above the region, suggesting that geological activity was at play. The surface surrounding the heart-shaped region was mountainous, while the eastern part of Tombaugh Regio featured a darker, more heavily cratered surface with older and more complex geological features. This unexpected diversity in the landscape led scientists to believe that Pluto's surface was not static; rather, it was actively changing, reshaping, and evolving over time. As scientists pored over the images returned by New Horizons, one discovery stood out: the presence of honeycomb-like structures in the Sputnik Planitia region. At first, these structures might seem mundane, just another feature of Pluto's varied and exciting surface. However, the true significance of these polygons only became apparent later. They seemed to suggest that Pluto's surface was being influenced by internal forces, a discovery that defied previous assumptions about the planet. These honeycomb structures appeared similar to the kinds of patterns that form on Earth due to the movement of molten rock, a process known as convection. Convection occurs when hot material from below rises to the surface, cools, and then sinks again. Could this mean that Pluto was geologically active, with convective forces shaping its surface? If so, it would mean that Pluto, long thought to be a lifeless rock, might still harbor some form of internal heat, allowing it to undergo geological processes. The idea that Pluto might have internal heat was a revelation. For decades, scientists had assumed that Pluto, so far from the Sun and so cold, could not possess the internal heat required to drive geological activity. But the discovery of these polygonal patterns suggested otherwise. These processes of internal heat and surface renewal could also explain the relative youthfulness of certain regions on Pluto. The planet's surface, it seemed, was not as ancient and unchanging as we had believed. Instead, it was being continuously reshaped by geological forces beneath its icy crust. This discovery had profound implications for our understanding of Pluto, and even for the search for life beyond Earth. If Pluto still had internal heat, it could harbor subsurface oceans beneath its icy shell, potentially creating an environment where life could exist. While there was no direct evidence of life on Pluto, the discovery that the planet had geological processes similar to those on Earth challenged the idea that life could only exist in environments that were warm and Earth-like. Could other distant worlds, once thought to be barren and inhospitable, also harbor the conditions necessary for life? This question now seemed more plausible than ever, expanding our view of where life might thrive in the universe. In addition to the discovery of geological activity, the data from New Horizons revealed an even more astonishing feature of Pluto, its atmosphere. For years, scientists had assumed that Pluto, with its distant, icy environment, had no atmosphere or a very thin one at best. But the high-resolution images and data from New Horizons showed otherwise. Pluto has a tenuous atmosphere, mostly made up of nitrogen, with traces of methane and carbon monoxide. The discovery of this atmosphere was groundbreaking, as it suggested that Pluto's surface and atmosphere are interconnected, with the planet's low temperatures and the faint sunlight creating a dynamic environment. The seasonal changes in Pluto's atmosphere were particularly intriguing. Unlike Earth, where water is the primary driver of weather systems, Pluto's weather is driven by the behavior of gases such as nitrogen, methane, and carbon monoxide. These gases undergo phase changes as Pluto moves through its orbit, which can lead to dramatic changes in the atmosphere. At times, these gases freeze and fall as snow, while at other times they are released into the atmosphere when the sun's faint light warms Pluto's surface. This dynamic behavior suggests that Pluto experiences seasonal cycles, though these cycles are vastly different from those on Earth. The presence of such seasonal processes on Pluto, in combination with its geological activity, painted a picture of a planet far more alive and complex than anyone had anticipated. As New Horizons continued its mission and sent more data back to Earth, scientists uncovered even more extraordinary features of Pluto's landscape. One of the most remarkable was the discovery of vast, rugged plains, marked by giant craters and deep valleys. Some of these craters showed signs of recent resurfacing, suggesting that Pluto's surface is still undergoing changes. In some areas, the craters had ice walls, which, when closely examined, revealed intricate layers of ice and frost. These features hinted at the possibility of ongoing processes, such as erosion, that were continually reshaping Pluto's surface. Even the rugged mountain ranges on Pluto, previously thought to be static and unchanging, were found to be made of giant blocks of ice. These mountains were not made of rock, as we are familiar with on Earth, but of frozen water and other volatile substances. These discoveries were mind-blowing. For a planet located so far from the Sun, where temperatures can drop to -375 degrees Fahrenheit, -225 degrees Celsius, it was hard to imagine how such processes could occur. Yet, the data sent back by New Horizons indicated that Pluto's surface was anything but static. It was an active, dynamic world, alive with geological and atmospheric processes that we were only beginning to understand. The close flybys of Pluto allowed New Horizons to capture incredibly detailed images, revealing a vast range of features that had never been seen before. From the honeycomb-like ice structures to the towering mountains of frozen water, Pluto appeared to be a world of contrasts and surprises. Some of the landscapes even resembled familiar features on Earth, such as icy deserts and barren, rocky plains. Other areas looked like freshly fallen snow, as though the surface of Pluto had been shaped by powerful forces in the past few million years. In addition to its rugged terrain, Pluto also revealed evidence of erosion, which scientists believed was caused by the subtle movements of ice over time. This erosion was particularly visible in the deep canyons in the northern regions of the planet, which had been shaped by the slow flow of nitrogen and methane ice. These icy rivers and streams suggested that Pluto's surface had undergone significant changes, which could have been driven by the planet's internal heat. If Pluto's surface was still being reshaped by internal processes, it would provide further evidence of the planet's dynamic nature. New Horizons' close encounter with Pluto also revealed some of the most astonishing images of the planet's polar regions. The photos showed complex layering in the ice, with blue and yellow hues indicating different layers of material. The topography of Pluto's polar regions looked like nothing we had seen before, with vast chasms and towering ice peaks stretching across the surface. These features suggested that the poles of Pluto were not frozen and inert but were dynamic and constantly changing, shaped by seasonal variations in the atmosphere and surface processes. As the New Horizons mission continued to send back more data from its flyby of Pluto, scientists began to realize just how much they had yet to discover about this distant world. The more they studied the data, the more they were amazed by the complexity of Pluto's surface, atmosphere, and internal structure. Pluto, once considered a lifeless, frozen world, had turned out to be a place of geological wonder and atmospheric activity. It was a planet unlike any other in our solar system, challenging our assumptions and expanding our understanding of the possibilities for life and activity in the outer reaches of space. Since its flyby, the discoveries about Pluto have continued to astonish the scientific community. The data collected by New Horizons has reshaped our understanding of planetary science, not just with respect to Pluto, but also with regard to other distant worlds in the Kuiper Belt and beyond. The fact that Pluto, with its frigid environment and distant location, could harbor internal heat and geological processes suggests that other bodies in the outer solar system could also be more active than we previously thought. In the years since New Horizons' close encounter with Pluto, scientists have continued to analyze the vast amounts of data it returned. Each new discovery adds to the growing body of knowledge about this enigmatic world, providing new insights into the processes that shape the planets and moons in our solar system. Pluto, once dismissed as a cold, dead rock at the edge of our solar system, has proven to be a much more exciting and dynamic place than we ever imagined. And as we continue to study Pluto, we are reminded of just how much we still have to learn about the vast, mysterious universe that surrounds us.